Hello friends, ನಿಮಗೆಲ್ಲ KPTCL KE exam preparation ಗೆ ಸ್ವಾಗತ. As you already know that we are solving 2019 PGCET question paper of electrical sciences, and this video is the part 3 of our video lecture. Let us look into the questions plan. So this question is basically about the control systems. As you can see here that a transfer function is given, friends. So transfer function is given in the form of 16 divided by s square plus 4s plus 16, and we need to find out what is the time taken for the first overshoot. Okay, let's try to understand the meaning of overshoot first before we get to the complete solution. So peak time with respect to overshoot is with respect to the response of a system, and the response happens during first time. Right? As you can see, peak time is nothing but the time required for the response to reach the peak time for the first time, and the first degree of the time response is 0. Okay, let's look into the solution, friends. Okay. As you know that for this problem, whatever the transfer function is given, okay, we need to first of all understand this transfer function. Okay, there is actually a standard form of a given standard function. There is actually a standard form for the transfer function. Okay. So this standard form is written in the form of omega n square divided by s square plus 2 zeta omega ns plus omega n square. Okay. Before we get to know the actual solution, we should be in a position to understand the standard form of equation. Okay. So whatever I have written now, this is called as a standard form, and this is essentially required for us to get to know the complete solution. Right? Let us begin with the solution, friends. Then, as you know that if we have the proper understanding of standard form, then this equation we can consider for our further analysis. Okay. Now this equation, if we try to compare with omega n square divided by s square plus 2 zeta omega ns plus 16. Okay, simply by comparing these two equations, we can write down that 2 zeta omega ns is equal to 4 plus, and we can also write down that omega n square. Just by comparing the equation, we can write down that omega n square is equal to 16. So if omega n square is equal to 16, we need to say that omega n will be equal to 4, which is nothing but square root of 16. Now, what is the outcome of this explanation is, we have first of all identified that omega n is 4 radians per second. Along with that, we have also made a comparison, and we got to know that 2 zeta omega n s is equal to 4s, so that we can write down that 2 zeta omega n is equal to 4. Right? So just by comparing these two equations, we got to know two important things. Now let us look into our solution, as we have to calculate what is called as TP, the time for the first peak overshoot. That is, in this problem, actually we need to get to the solution for what is called as TP. Okay. So TP is given by n5 divided by omega d. Whereas omega d as you know that it is a damping frequency and its unit is radians per second. Okay, and omega d can be calculated as omega n into square root of 1 minus zeta square. Right, as we already know that we have obtained a solution here that 2 zeta omega n is equal to 4. Okay, as we know that 2 zeta omega n is equal to 4, that is 2 zeta omega n is already 4 is equal to 4. Meaning to say that we can have a solution for zeta as 1 over 2. Okay, we can have a solution for zeta as 1 over 2, right? So which is essentially 0.1. Okay, let us keep this solution aside. That is zeta is equal to 1 divided by 2, that is 0.1. Let us move on to the next part of solution. So for your easy understanding, I shall mark the answer whatever we have obtained as zeta is equal to 0.5. Right. Now we need to apply this formula, that is omega d is equal to omega n into 1 minus the square root of 1 minus zeta square. So as you know that omega n is equal to 4 into 1 minus, we have got the answer as 1 by 2 square. Right. So this will be equal to what? 4 into 1 minus 1 by 4. So if you can solve for this further, then you get the solution that which is 4 minus 1 divided by 4. So the final solution will be what? 4 root of 3 by 4. Right. So what will be the solution of this then? 4 by, so square root of 4 will be 2 into root 3. Right. So the solution for, as we were discussing here, 4 into 4 minus 1 divided by 4. The solution of this will be what? It will be 2 root 3. You can just go to the solution. 2 ones are 2 2. So 2 root 3 will be the final solution for omega d. Now if we know that omega d is equal to 2 root 3, then what has to be calculated? Tp, which is n pi divided by omega d. So the solution will be what? As you can see here, Tp will be n. So n will be, since we are calculating here for the first overshoot, so that n will be equal to 1. Okay, so solution will be 5 divided by 2 root 3. Okay, so as you know that 5 divided by 2 root 3 seconds is the option C, which is the expected and correct answer for this question. Okay friends, we shall move to the next part of question then. It is with respect to again control system. Which one of the following is the transfer function of a linear system whose output is t square t minus t for a unit step input? So let us try to understand the solution. As we know that the Laplace transform of an output for a given system is given as output of a system is equal to input in x of s into transfer function h of s. That is y of s is equal to x of s into h of s. Okay, that is, as you know that h of s, from this we can write down that h of s is equal to y of s divided by x of s. This is the standard way of writing the transfer function. That is Laplace transform output divided by Laplace transform input. Just try to get the solution for this. Now the equation in time domain becomes is n factorial divided by s of n plus 1. Now let us look into the complete solution, friends. So whatever is given as y of t in time domain, that is t square minus t to the power 2t becomes 2 divided by s plus 2 to the power 3. So whatever we have written as y of s is the conversion of time domain equation into the Laplace form. Right now, x of t is equal to u of t. That is, for a unit step input, it will be what? U of t. So if we convert this in s domain, then x of s is equal to 1 by s. That is, this is the conversion in s domain, 1 by s. Now to try to understand that, we have here y of s given as 2 divided by s plus 2 into 3, and we have x of s given in the form of 1 by s. Right. So since we want to obtain h of s, which is nothing but what? 2 divided by s plus 2 to the power 3 divided by 1 over s. So that the complete solution becomes 2s divided by s plus 2 into 3. Okay. So it is supposed to be 2, I guess. So you can go through the complete answer key available at the KEA website. So the answer for this question is option C, which is 2s divided by s plus 2 into s plus 2 to the power 3. Now we shall go ahead and discuss one more question. So this is related with again control system, where it is with respect to the RH criteria. Let us try to understand, friends, what has been given here. So the first column of routes array is given, and how many routes of the corresponding characteristic equation are there in the left half of the S plane, that has been asked. Let us look into the solution, friends. There are total 5 routes are there, as we can count. There are total 5 routes: 1, 2, 3, 4, 5. And as you can see here, there is 2 sign change in first column. As you can see here, from here to here, plus is changed to minus. So this is first sign change, and here to here, as you can see here, this sign changes from negative to positive, right? So as we know that there are 5 routes, out of which there is 2 sign changes, right? So they mean to say that 2 routes are there in right half of the plane. But what has been asked is how many are there in the left half of the S plane. As we have identified that there are total 5 routes, out of which 2 are at the right half of the plane. So that 5 minus 2, 3 routes of the characteristic equation are there in the left half of the S plane. Okay, this is the expected answer, which is option C. Now, next question is a very easy question. It is about a branch of delta circuit as impedance √3Z, and each branch of the equivalent Y circuit we need to control. Okay. Basically, this is a very simple example related with delta to star conversion. That is, there is a branch So there is a branch of impedance given like this. And each branch has an impedance √3Z. Each branch has impedance √3Z. This also has √3Z. Now this delta circuit, if it is converted into star, if a given delta circuit, if it is converted into star, then we need to calculate each of the element. For each of the element, whatever is given over here as √3Z, how much it will be in the form of star connection. Okay, so whenever we have to convert delta to star, we need to be very much familiar with the formula given over here. Because whenever we have to convert a delta element to a star element, this is the formula we need to use. That is, so here the values are given in terms of resistance, but always you can make a changeover then in the form of Z, that is impedance. Okay, so let us try to calculate the impedance by applying the formula given over here. So the value of star connection, Z value for each element is whatever is required is equal to, as you can see here, it is RAB, RAC, that is two branches of this delta circuit we have to consider. So if we consider two branches of delta circuit, then it will be √3 into Z into √3Z divided by, it is addition of all the three values. So all the three values are nothing but what? √3Z plus √3Z plus the √3Z. So solution for this will be what? √3 into √3, which will be √9. √9 means square root of √9 means again 3Z square divided by it. The summation is √3Z plus √3Z plus √3Z. So it is 3 √3Z. Now if we can solve for this, Z and Z, 3 and 3 gets cancelled over here. So that in the numerator term we have Z and in the denominator term we have √3. Right. So the correct solution for this is Z divided by √3, which is option B. Next, we can move ahead to the next part of question. AC source of RMS voltage 20 volts with impedance, internal impedance of 1 plus 2j ohms and load impedance of 7 plus 4j ohms is given. We need to calculate the reactive power. Remember that whenever we need to calculate reactive power, it is about the calculation of Q, or else it is nothing but what? Sin phi component of power. It is actually sin phi component of power. So by just looking at the circuit, we can easily write down that the total current in the circuit will be equal to V divided by ZL plus ZS, right? So we know that V is 20 at an angle 0 degrees divided by ZL plus ZS, right? So ZL plus ZS will be how much? It will be, as expected, I can just write out this separately here. So it is 1 plus 2J plus 7 plus 4J. If I can add the real and imaginary parts, it becomes 8 plus J6. It will be 8 plus J6. So if I can solve for this, then I'll be able to get the solution by 20 at an angle minus 36.86 degrees is the answer for current. Right. Now, once we have the solution for current, then we can actually calculate power. We can now go for the calculation of power. So we know that very simple formula for power is I square into ZL, I square into ZL, because we have to calculate the reactive power consumed by load. Now, out of whatever we have obtained as a solution as Q at an angle minus 36.86, let us consider only the magnitude of this, so that whenever I say that it is a square, it will be 2 square, which is equal to 4 into ZL. ZL is 7 plus 4J. So it will be 28 plus 16J. Remember that the calculation of power, whatever we have obtained here, is a two-part solution, which is in the form of P plus J Q. Whereas P is the real power and Q is the reactive power, right? So since Q is the reactive power, we can compare this and obtain the solution. That the required answer for this question is 16 VAR, that is 16 volt ampere reactive, right? Now this is about semiconductor physics. The question reads about the uniformly doped N-type silicon sample with a sample resistance of 0.5 ohms, and the electron mobility is given as you can see at 0.5 ohm centimeter is given as a resistivity of a uniformly doped N-type semiconductor material, whereas the electron mobility is 1250 centimeter square volts per second, with the charge of each electron is 1.6 into 10 to the power minus 19. So charge of an electron is 1.6 into 10 to the power minus 19 coulombs. Now we need to calculate ND. Okay, in this question we need to calculate ND. It's the donor impurity concentration. Now, donor impurity concentration can be calculated with the given formula, that is ND is equal to P divided by 2 into mu n. Whereas we know that P, so we already know that P is 0.5 and in the denominator it is Q. So Q, we know that is 1.6 into 10 to the power minus 19 into mu n. So mu n is nothing but what? Electron mobility, which is 1250. Okay. So if we can solve for this, then we'll get the answer as 2.5 into 10 to the power 15 centimeter cube. Okay, so 2.5 into 10 to the power 15 centimeter cube, which is option C. The answer for this question is 2.5 into 10 to the power 50 centimeter cube. Let us look into the next question. So this is again with respect to a very simple Zener diode circuit, and we need to calculate the minimum value of R so that the voltage across it does not fall below 6 volts. There is a simple circuit given over here with a battery source and resistance and Zener diode, and we need to concentrate towards this resistor so that the voltage across the resistor does not fall below 6 volts. Now, if we can look into the circuit with the details given, then we'll be able to understand that the voltage across Zener diode is Vz, and from the circuit given information, the maximum voltage available is 10 volts. Right. Now, we can calculate the current through resistance as Vmax minus Vz divided by R minus IE. Right. So, if we can calculate this, then Vmax, as we know, that is 10 volts minus Vz is 6, and the R, the value of R given over here, this value which is 50 minus IE, that is knee current, right? So I can calculate this as you can see here, knee current is given as 5 milliamperes. Its knee current is 5 milliamperes that I can consider. That is, value for this is 5 milliamperes, right? So if we can solve for this, then the current IR will be 75 divided by 1000 amperes, right? Now, if I have to calculate R, as we know that this Zener, the role of Zener diode is to maintain a constant voltage of 6 volts. Now I can calculate resistance as V divided by IR, which is 6 divided by the solution whatever we have obtained. So remember that this solution for IR is actually written from the equation given here, that is 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 equal to IN plus IR. Now if we can solve for R, we should be able to get the solution as 80 ohms. Which is option 2 here. Now this question is with respect to the concept of field theory or electromagnetic waves. Now what we need to calculate is the induced EMF in the coil at the instant t is equal to 2 seconds. So it is with respect to a coil, okay, which is the equation of this particular coil with respect to the flux linkage is given as phi is given by phi of t is equal to 2t square minus 20t plus 40. Right. So whenever time t is equal to 2 seconds, we need to calculate the induced EMF. Let us look into the solution of this question. So solution is pretty easy. So for this kind of questions, we need to start our solution with a basic equation that E is equal to minus d5 by dt. That is, E is equal to minus d by dt of. So we need to get the derivative of this equation, that is 2t square means it becomes 2 into 2t minus 20t will become 20 plus 0. Solution for this will be what? Minus 4t minus 20. Since t is already mentioned as 2 seconds, the solution will be what? Minus 4 into 2 minus 20. It will be equal to minus 8 plus 20, which is equal to 12 volts. Okay, 12 volts is the required answer. 12 volts, option B. Okay, this is with respect to a very simple question of full wave rectifier circuit with a center tap transformer, and if the peak voltage across half the second is 40 volts, and if the diodes used are ideal diodes, the average output voltage is 40 volts. Now let us look into the last practical solution for this particular part of our discussion. That is 8-bit DAC produces output voltage of 1 volt. 8-bit DAC produces output voltage of 1 volt for a given digital input. Okay, given digital input is 0, 0, 1, 1, 0, 0, 1, 0. Now, if a particular DAC, whatever we are discussing, if it is giving 1 volt for the given input, that is 0, 0, 1, 1, 0, 0, 1, 0, then what is the maximum output? What is the maximum output we can get from this DAC? Okay, let us try to get the solution. Okay, here first of all we need to convert a given binary number into its decimal equivalent. 0, 0, 1, 1, 0, 0, 1, 0. So it will be to the power 0, to the power 1, to the power 2, 3, 4, 5, 6, 7. It will be 0 here plus 0 plus 2 to the power 5, 32 to the power 4, 16 plus 0 plus 2 plus 0. So it will be 32 plus 16 plus 2. It will be 50. Okay. So once we know that 50 is nothing but what? We know that 0, 0, 1, 1, 0, 0, 1, 0. It is binary. 50 is decimal number. Now, if I have to calculate the maximum output voltage, then there is a formula. So what is that formula? It is V out is equal to VFS divided by 2 to the power n minus 1 into input voltage. Okay. Now we know that a DAC produces output voltage of 1 volt. So V out is equal to 1. And VFS is nothing but what? The full scale reading of DAC. That is the maximum voltage which we have to determine. VFS. 2 to the power n. So since we are discussing about DAC and we know that there are 8 digits totally, so that n will be equal to 8. This 2 to the power 8 minus 1 into input voltage. Input voltage is nothing but what? We have converted this number into decimal, right? So the solution for this we can obtain now as we can obtain as it is equal to 1 is equal to VFS divided by 2 to the power 8 is 256. 256 minus 1 is 255 into 50. So that VFS, the maximum voltage, is 255 divided by 50, which is 5.1. Okay, so 5.1 is the answer for this question, which is option D. Okay friends, thank you for your patience watching. Please subscribe to this channel and support us for our new initiative. Thank you all.